We're going to take our mini bundt cake pan and we're going to pour some water in it. We're going to make an ornament out of this by freezing the water, but make sure you put enough in it so that you can pop it out later. And you can make multiples of these because you will have a lot of birdseed. Take that birdseed and we're going to dump a little bit in there. You can save some to make more of these, or you can only do one. I don't like to put too much on here just so I can do multiples, but do what you please. Now we're going to put it in our freezer. Do you know that the freezing point for water is 32 degrees? And guess what? Your freezer can get all the way down to 0 degrees. So it should be able to freeze that really fast, but you can wait a day and it should be done. Now we can pull this out. Look, it's frozen all the way through, and this will be our ornament. We are gently going to pop this out so that we can reuse this and make more ornaments with the birdseeds that we have left over. Next, take the string and put it through the middle of your ornament. And then at the top, double knot it, or you can single knot it. But we're going to take these outside to hang. Find a good tree to hang them on so that the birds can enjoy. Let's move on to our next experiment. Take out your 4 cups and lids. And what you're going to do is on the bottom ridge of the cup, you're going to put a black mark on each of them. Make sure you make all of them even because we're going to put water in each of these and they all have to be equal. Now with those ridges done, pour the water in. And again, make sure that it's even. And do this for all 4 of them. Once this is done, put them in the freezer. And pull them out 24 hours later so that they are frozen. Next you want to get into your kit and take out the K and T cups. This is kosher salt on the left and on the right table salt. Kosher salt is a larger salt. As you can see, it's bigger right there. Table salt is smaller. As you can see, on the right is the table salt and the kosher salt on the left. Which one do you think is going to help dissolve the ice quicker? Kosher salt or the table salt? Put it down in the comments for us. Get one of your ice cups ready to start this experiment. We're going to start with the table salt for our fish experiment. Let's go! Make sure you get it all in there. We'll be timing this for 10 minutes. Next, get a permanent marker and mark where it leveled off. You definitely want to use a permanent marker for this so that the water and condensation does not erase it off the side of your cup. But see, look at the difference there. It's not too much of a difference with all that table salt. Look at that top. It looks like a snow cone. It doesn't look like it's continually melting that ice. It doesn't look like it did much. It's very hard. So I don't know. I don't think the table salt did much into melting that ice. What do you guys think? Okay guys, let's get another ice cup and let's dump the kosher salt down and see how well this dissolves the ice. Remember, we're going to time this for 10 minutes again. It looks like it might be working a little bit better than the table salt, but we'll have to see. We're almost to our 10 minutes, guys. How much do you think it's going to melt? Put it in the comments. Do you think more or less when it comes to the table salt? Let's get ready to stop it, guys. 4, 3, 2, 1, 0. Let's stop and let's see how much this is melted. It looks like a lot compared to where it started. If you see, there's that black line where we started at, and it's stopping right here. It looks like, what, you think maybe a fourth of the ice is going by? But it looks like a lot, and it looks like the salt has moved all the way down to the bottom compared to that table salt where it was all up at the top. But that looks like a lot. Here we are comparing the table salt to the kosher salt. The kosher salt's on the right, and if you can see from the top, it's still melting there, but it doesn't look like it's melting that much on the left-hand side with the table salt. And if you look at the table salt on the left, it barely melted from where it started, while there's a lot of melt on the kosher salt right here on the right. Grab your next cup of ice, and next we're going to go with Preston. It is a driveway heat concentrated ice melter. It's supposed to be 4 times more effective on ice and snow, so we'll see how much better this does than the kosher salt and the table salt. Hopefully a lot better. Remember, we're going to do this for 10 minutes, and it looks a lot thicker than the kosher salts. This might melt quicker than the salt. It looks a lot more concentrated too, and let's see how this goes. Put in the comments what you think is going to happen. Here we are at 3 minutes. Let's check the side to see how much it has melted. It looks like it's melted a lot there, guys. You can already tell that some of the ice melts is down to maybe a third of the way. See? So it looks like this is melting a lot better than the kosher salt and the table salt. Here it is next to the kosher salt. Look at the right. It's already past the kosher salt. Here we are at 5 minutes in, and look, it's almost halfway. This is doing really good compared to the salts. Here we are at almost 8 minutes, and look at it. The ice has melted a lot of that ice into water. There's a lot of water up top, and all you can see is ice melts. It's not frozen like the table salt, so it looks like it's doing a really good job. Here we are at our countdown, guys. 3, 2, 1, 10 minutes stop. So now let's see how much it has melted compared to the other ones. Whoa, that is a lot of ice that has melted, and it looks like it's gone past halfway. Do you think like a third is left? It's not even, but a lot of ice has melted on here. Here's a view from the top, and that is a lot of melted ice. Look at all that water, guys. Here it is compared to the other two. The table salt on the left, in the middle is the kosher salt, and here's the Preston on the right. Let's get ready for our last experiment by grabbing our last ice cup. This one will also be another ice melt, and it is called Traction Melt CI. It is also a lot thicker and heavier than the Preston. So we'll see if this is any better than the Preston and melt a lot more, or will it melt a lot less. Put your answers in the comments and let us see. It's an experiment and test your hypothesis. Also, the ice melt is made out of liquid magnesium chloride. It's supposed to be safer than other ice melts, so we'll see how great this is at melting. Here we are at 3 minutes. Let's check the side and see how much it has melted. It doesn't look like it has melted as much as the Preston, but we'll keep on going until the 10 minutes is up. And look at that, compared to the other ones that have continued to melt, the Preston has almost melted all of that ice. And we're about halfway with the kosher salt, and there's still a lot of ice to melt on that table salt. Here we are a little bit past 6 minutes. Let's check it out and see how much it's melted. It looks like there's still a lot of ice left to melt on here. I think maybe a third of it has melted. Here's our countdown now. 3, 2, 1, stop. Here it is. It looks like it's a little bit above halfway. So it doesn't look like it melted as much as the Preston, but it did pretty good compared to the table salt. Let's check it out next to the other ones. So as you can see, it did a little bit better than the kosher salt, which is the second one. That table salt is still melting away, and it looks like the Preston has fully melted all of that ice. So it looks like the Preston has done the best, and then the Traction Ice Melt CI, then the kosher salt, and then the table salt. So basically the salt is dissolving and creating a film of liquid water. And that's going to be on the surface, as you can tell at the top usually, why the salt is always on the top. It lowers it to a freezing point below the ice's temperature, and because of this salty water, it is starting to melt. That's why the salt melts. the ice. And then that's why some people use kosher salt when they throw it out, but it doesn't work as quick as ice melts. And basically, ice melts kind of works in the same way. It interacts with the water and the ice to form a liquid brine, which makes it heat up the ice, and then that's why it melts. Because it spreads out on the ice, and then it breaks it up, all the bonding to the pavement, and that's why you see a lot of ice melts being put on the roads and the driveways, because it helps loosen it up quicker so that you can shovel it. The ones we use today are good, but sometimes ice melts can be bad for plants and animals, so you gotta look out for that. Next, grab your 2 cups. We're going to fill these up to the bottom ridge where it turns white. On one cup, you're going to put W for warm, and then on the other cup, you're going to put R for regular. This is just going to be regular tap water. Get ready, guys. We're going to do a great experiment with these bath bombs, and it's going to be so cool. Start off by filling up the R cup, or regular water cup, up to that white line. Make sure that it's even. Now, guys, get ready for this bath bomb experiment. We're going to drop one of these in the regular water. But make sure that you have a timer to time it for 5 minutes. And we're going to go now. This is going to be so magnificent, guys. This is going to be the greatest. Guys, let me know in the comments what you think is going to happen, or when you think it's going to fully dissolve in the 5-minute time frame. Let's keep track of this, guys. Oh, man, it's bubbling up. What's going to happen? It doesn't seem to be going that fast, guys. But yeah, I have faith. My guess is like 3 minutes. What is your guys' guess? Put it in the comments, guys. It's going a little bit, but it's still, you can still see the ball right there. We need to make sure the whole thing dissolves. Since it's not going so fast, I'm going to speed it up, guys. We're going to see if it dissolves faster. It looks like the cup is overflowing because of the chemical reaction, but it does not look like it is melting that bath bomb. It might look like it's dissolving, but if you put your hand and poke it, you can see that that ball is still in there, and it isn't dissolving that fast in the regular temperature water. It looks like the bath bomb didn't melt all the way through with all 5 minutes done. Next, we're going to take that other warm water cup, and we're going to fill that up to the white line again. This time, we're going to take the tap water, and we're going to put it into the microwave for 2 minutes. This can get very hot, so make sure that you get a parent to do this for you, because you don't want to burn yourself with hot water. Another way you can do this instead of microwaving it is using hot tap water too. Just be safe. This time I think it's going to be very cool, guys. Get your timers ready again, and we're going to get ready to drop this bath bomb. In the comments, tell me what you think is going to happen with the warm water. And here we go. Whoa! Whoa, it's fogging up our screen, guys. That is crazy. You guys seeing this stuff? I wonder what it's doing on your end. Let us know in the comment how fast yours is dissolving. I can't even see through our camera right now. Hey guys, it looks like it dissolved. I'm going to double check just to see, and I just put that spoon in there and it's not there anymore. But it's just fizzing a little bit. It's just the reaction ending. And as you can see, if you mix the baking soda and citric acid, which is found in these bath bombs, and add it to water, it will make foam and bubble. But the difference between the two experiments is one was in regular water, room temperature, and the other one was hot. So the hotter your bath water is, the faster your bath bomb is going to fizz. And due to that, it's going to heat up and it's going to create thermal energy, with the water making individual water molecules bounce around. And due to them colliding, it makes it fizz and bubble more, which makes it dissolve. I hope you had fun. Thanks for doing these experiments with me, and check out the other ones that we have at kckpl.org.